if something's bounded above, you can find some number that is bigger than every term in the sequence. Is this number unique? No. What do I mean by unique? Is there only one M? No. See, look, if I have a sequence and I found that M is 10, well, 11 would work as well. 11.3 would work. Things like that. So M is not unique, but it is bounded above if such an M exists. Here's an example of a sequence. So the first term is 1/2, the second term is 2/3, the next term is 3/4, the next one is 4/5. Who knows what the next term is? 5/6. And I'm looking at the numerators increasing by 1, the denominators increasing by 1. This one is bounded above by 1. This sequence is bounded above by 1. In fact, if I kept on with this pattern, the numerator is always one number smaller than the denominator. So, eventually I'd get, 1,000 over 1,001. And so the fraction is approaching the number 1, is bounded above by 1. It's bounded above by 2 if I wanted to say that. But certainly I could say it's bounded above by 1. How can I write the a sub n term for this? It would be n over n plus 1. And what we're going to write are things like this. The limit as n approaches infinity of a sub n equals 1 in this case. Now we have a bounded below. So a sequence is bounded below if there is some number. This time they use a lowercase m for below. If there's some number, lowercase m, such that lowercase m is less than or equal to a sub n for all n greater than or equal to 1. Now, I don't know if you've picked up on this yet. A lot of times, students in 9th grade or 8th grade probably haven't picked up on this yet. But if I use a lowercase letter and an uppercase letter, that's two different variables in math. So just like, it's as different as x and y. So here they use lowercase. Here's an example. Well, I don't have an example. Never mind.